Assalamualaikum warahmatullahi taala wabarakatuh and good day for everyone. My name is Muhammad Fahmi Burhan bin Burhanuddin, and for my final year project, I'm studying acetylated starch with silver nanoparticle via microwave irradiation method for biofilm application. My project was supervised by Dr. Roshfima Rasid Ali. Before we start into the content, here is the table of content containing five chapters. Basically, they starting from introduction, next to the objective, through the methodology, result discussion, and finally conclusion for the entire project. So as for the starters, packaging is highly employed to protect food from contamination, and usually plastic packaging always end up as single-use plastic that contribute majorly as solid waste problem. Thus, to cater this problem, food industry always been the largest industry that working on and demanding on biodegradable packaging. This brings to the real reason on why we use plastic. Basically, approximately there are 600 million foodborne illnesses due to foodborne pathogen such as E. coli and Salmonella. However, this exposure comes from the processing from farm until the transportation process. And to counter this problem, silver nanoparticle is a potential application to be implemented on the plastic packaging in order to promote antimicrobial properties as well as inhibiting the microbial growth. Furthermore, there is a recent concern on process path for synthesizing silver nanoparticle that is related into the toxicological process path. This toxic process due to the employment of chemical reagent as the reducing agent in the conventional way. So in order to cater this problem, the employment of starch as a potential reducing agent can be known as a green synthesis for silver nanoparticle. On top of that, the employment of starch can lead to a controlled nanosize of silver nanoparticle. Okay, so for the silver nanoparticle can be synthesized from the silver solution via reducing agent. Generally, there are three synthesis methods. The first one is the chemical method. Chemical method is known for the conventional process path. And the next one is the physical method. Last but not least is the biological method. And another unique part of this silver nanoparticle is the antimicrobial properties that can be implemented to prevent bacteria, fungi, and virus. From these unique properties, silver nanoparticles are widely implemented in a medical equipment and supplies. So the next part is the implementation of the PLA film. Basically, PLA is widely utilized in the food packaging industry. Another special traits about PLA is the excellent degradability, as well as can incorporate a wide range of metallic nanoparticle to improve the packaging properties. So as for the research gap, the first one is the demand and the application of biodegradable plastic as packaging. Another problem is come from the toxicological synthesis in order to process silver nanoparticle and the foodborne accumulation on the food product as well as on the plastic packaging. There are three main objectives for these studies. The first one is to synthesize the silver nanoparticle by using acetylated starch with different parameters via microwave irradiation method. And next one is to fabricate the biofilm from PLA and acetylated starch based silver nanoparticle by using solvent casting method. Last but not least is the characterization and analysis for the synthesized silver nanoparticle. There are four key points in methodology for the studies. The first one is the synthesis of silver nanoparticle mediated starch via microwave irradiation. Basically, there are two parameters to study the synthesis silver nanoparticle. The first one is the ratio effect and the second one is the microwave exposure time effect. Second key point for the methodology is the characterization of silver nanoparticle. The characterization consists of UVVs for both parameters, SRD analysis as well as the FTIR analysis. The third key point for the methodology is the preparation of PLA by solution casting method. And finally, we're going to mix the synthesized silver nanoparticle mediated acetylated starch into the PLA solution as the final product for this project. Okay, we come to the result discussion. The first one for the result discussion is the study of the effect of different ratio. So we can observe the formation of the silver nanoparticle through the color of colloidal suspension. The change from clear colloidal color solution to the darker color solution indicating the formation of silver nanoparticle. The higher the starch of ratio, the darker the colloidal color solution. And as the solution become darker, the solution get dry over the time. And the absence of starch will not result in reduction process to formation of silver nanoparticle. So the UV-vis analysis for the effect of different ratio studies, the UV-vis peak getting higher at the 430 nanometer. The higher the starch ratio, the higher the absorbance peak. The ratio at 25 to 25 has the optimum ratio for this loading. Meanwhile, for the ratio of 50 to 0, do not have any peak due to the absence of silver nanoparticle formation that initially do not have any starch to begin with. Thus, we can note that the formation of silver nanoparticle can only be formed with the presence of starch. Okay, for the second part is the effect of different exposure time studies. We can observe that the higher the exposure time, the darker the colloidal color solution. However, the solution at this 70 minutes has become more viscous than other solution. The UV-vis analysis shows that the exposure time can give a significant result in synthesizing acetylated starch mediated silver nanoparticle. The absorbance peak shows at the 430 nanometer. In this analysis, 70 minutes of time exposure give the highest absorbance peak and followed up by the 15 minutes of exposure. But then, at 70 minutes of exposure time has high viscous properties that makes the solution is hard to handle to be further studies. So for this analysis, we agree that silver nanoparticle in 15 minutes is an optimum sample to be further studied. For the XRD analysis, it's carried out to identify the crystallinity of silver nanoparticle. Basically, there are 4 peaks appears for the SRD analysis. The peaks are 37.4 degree, 43.4 degree, 63.1 degree, and 75.7 degree. And this correlation, the peaks value is related to the phase center cubic, which is FCC structure, and the lattice plane that related to this peak value has the lattice plane of the crystalline is 111, 200, 220, and 311 respectively. So for the FTIR analysis, the FTIR is conducted on 2 materials. The first one is starch and the next one is the synthesized silver nanoparticle. So basically from the starch, we can observe there is a wave number peak that relating the functional group existing within the starch. Silver nanoparticle exhibit the similar FTR spectra with starch. However, silver nanoparticle FTR spectra has a shifted peak. This might be related to the interaction of starch functional group and silver nanoparticle. There's also new peak occurred at 802 per centimeter due to the vibration mode of silver and oxygen bond. And another new peak we can observe occurred at 1282 per centimeter. That might be due to the presence of silver nanoparticle. Last one for the result and discussion is the fabrication of biofilm. So basically we have both PLA was fabricated by solvent casting method. The native PLA appears in white and fire colors. But then the physical properties for the native PLA is a bit brittle. And on the other side, we have the PLA modified by silver nanoparticle mediated acetylated starch that appear in brown in color and dark. But then the physical properties exhibit the same as the native PLA, which is brittle. So finally, we come to the conclusion. Basically, as for the conclusion, synthesis of the silver nanoparticle by using acetylated starch with different parameters via microwave irradiation method was successfully synthesized. And the fabrication of biofilm PLA and the acetylated starch-based silver nanoparticle by using solvent casting method was successfully fabricated. And lastly, characterization and analysis of silver nanoparticle was successfully achieved. Here is the list of the reference that be used for the entire studies. Thank you everyone for spending your time listening to my presentation, and I wish everyone a good day.